Hello to everybody. I am really happy to greet all the participants of the International Conference on Science and Technology Research. My name is Liudmyla Gryzun. The topic of my keynote presentation is Project Model and Activity in Pre-Service Teachers Training in Terms of Holistic Education. A few words about myself. I represent here National Pedagogical University of Kharkiv city, Ukraine, where I work as a full professor of a computer science department. I earned a master's degree in applied mathematics from the State University of Kharkiv city, Ukraine. I have also a PhD and second doctoral degree in pedagogical science, and the sphere of my research interest covers curriculum design in higher education based on scientific knowledge integration, creating STEAM content, IT tools for inquiry-based teaching and learning, artificial intelligence instruments for didactic problem solutions, and others. My recent successful projects you can see on the screen, among which my keynote presentations at the Eurasia Research International Conferences during last 2 years. My focus of current research activity is holistic approach to contemporary higher education. So, during today's presentation, I am highlighting the problems and difficulties of holistic approach realization in teachers training. Then I am going to cover practical aspects of this approach realization and represent the results of students' project activity focused on computer modeling building and simulations. Finally, I'm going to cover the results of the empirical research as for the impact of this activity on the pre-service teachers' learning outcomes. Learning the problems of contemporary education reveals needs for changes of mainstream educational paradigm. It is connected with worldwide tendencies for globalization, quick changes and renewing of technologies, knowledge integration of science branches, and definitely the rapid growth of knowledge amount which are to be learned during the students' vocational training. As a result, it causes challenges to university education. All of these tendencies must be reflected in the content of training of university students, as global science and employment market demand specialists who are ready to solve integral problems, have flexible system of knowledge, and are able to use it in related branches and adapt quickly to changes. Thus, it becomes really important to build the renewed approaches to students' training on the basis of new paradigms on the all levels of education. One of such a paradigm might be the holistic educational approach. According to works on the holistic theory, the core idea of holistic education is the cohesive development of the whole personality of a trainee, both on the intellectual and emotional levels, based on strong links between personal experience and real-life problems. There are some main pillars of holistic educational approach. It is aimed to build dynamic, commonized, and interconnected pedagogy, to form students' concentrated conceptual knowledge and the complex of transdisciplinary skills. Any trainee under this approach is considered to be active participant of learning process who is ready to interact with reality via his own cognitive activity. It allows to establish in the trainee's memory a great amount of strong links between concepts, and as a result to encourage students to investigate and apply what they know and can do to other subject areas. The analysis of the holistic education pillars, which makes a theoretical background of our work, testifies necessity to apply efficient instruments for such an approach implementation into contemporary teaching and learning. One of the instruments seems to be computer modeling, which expects both models building and simulation activity with them. According to didactic studies, computer modeling has high potential as for revealing interdisciplinary connections and facilitating their understanding by trainees. It allows to visualize phenomena, essence at real-time operation, learn dynamic changes, and investigate the phenomenon via active cognition. It also provides facilities of dynamic visualization and modification of the model, which allows students to develop their investigative intuition. Computer modeling in terms of holistic approach seems to be especially beneficial in training of potential science and mathematical teachers. Why is it so, actually? The matter is that teachers have to be cohesively developed themselves, and computer modeling provokes their cohesive development. Teachers need to understand clearly the links between elements of knowledge, which will allow them to render this understanding to their potential trainees. Finally, teachers must be ready to realize themselves holistic approach in their professional activity. Therefore, it's important for them to try on active tools and methods of teaching which are necessary for their future professional activity in terms of holistic education. Minding these benefits of computer modeling, we involved our students who are potential science and mathematics teachers. We involved them into the project activity focused on computer models building and simulations in terms of holistic approach realization. The research issue of the work was to learn the influence of these kinds of cognitive activity on the students' learning outcomes. During the research, the set of theoretical, empirical, and modeling methods were applied. Our students were involved into the project's activity within some their curriculum subjects, and the project topics offered to students were different, but all of them were focused on the design of computer dynamic models for learning various concepts, processes, and phenomena. Thus, all the projects embrace similar stages. At the first stage, mathematical model of the future computer model is created by the students. At this point, it is provided revealing the essence of the proper concept, its links with other concepts, defining of the dependencies which enable to illustrate and explore the concept, revealing the fixed model parameters and changeable ones, picking up proper graphic elements which are able to visualize dynamic changes, and also thinking over the tasks which are relevant to solve using the model. At the second stage, the mathematical model is transformed into computer one by means of proper software. In particular, our students worked within environments of GeoGebra software, MS Excel with VBA programming, Android application P3 Nets Toolkit, and others. The next phase is devoted to testing, debugging, and improving of the model. At the final stage, the development of didactic support as a set of specific tasks for future trainees is created to encourage their holistic learning. In particular, the scheme of work with the model is elaborated. The scheme of the simulation and computing experiment are determined, and the developed didactic support is integrated into the model environment with the help of proper control elements. Now I'm going to cover specific examples of students' project activity on the design of computer dynamic models. The first project task was to develop the complex of computer transdisciplinary models for school children. The models in complex built in GeoGebra software, and they are grouped in the sections according to the curriculum subjects: physics, algebra, geometry, biology, geographic, chemistry, informatics, and others. Each models in the model in the complex is represented in the complex according to the general scheme. It includes model title, change of the transdisciplinary links which are illustrated by the model description, dynamic model itself with the proper functionality, procedure of cognitive activity on the realizing the essence of the concept, which is a prototype of the dynamic model, and didactic support as a set of transdisciplinary tasks and real-life problems for forming holistic image of the said concept. There are some examples of models which were elaborated by our students. For example, it's model clock from geometry section, which covers the chain of transdisciplinary links between geometry, algebra, and physics. In particular, potential trainees are expected to solve problems like this one: operate the model, turn the clock hands, set the time according to figure, and detect degree measure of angles made by the hands. Also, it is offered to students to use the model with different parameters and calculate degree measure of different angles, which are expressed via algebraic expressions. Operate the model to express the given values of the speed and measure of meters per second, and definitely different real-life problems which focus on the time as a precious social theme. The episodes of learning activity is shown on this slide. So presented transdisciplinary tasks done with the model focus on forming holistic understanding of a clock as a physical and geometrical device, time as a physical concept and social phenomenon, and geometrical, algebraic, and clock sense of degree measure of angle, and other investigative tasks are also possible to solve within the model. Some other examples of models of this complex: model number system, which covers the chain of transdisciplinary links between informatics and algebra. The model canon, which illustrates the links between algebra, physics, geometry, and history. And all the our models, I'd like to emphasize that all of them are dynamic ones. There are special sliders which allow to change parameters of the model and see immediately the changes in model's behavior, and in such a way make conclusions and stimulate learning investigation and stimulate actually learning activity with the model. In such a way, the model helps to learn cohesively concepts of physics, algebra, geometry, and even history. There are some examples from this complex binary tree from section informatics, similarity model from section geometry, and others. On the whole, students' project activity on the project number 1 provides main principles of the holistic education: connection establishment, personal cognitive activity, focus on the ruining boundaries between subject fields and reality, and prepare them for holistic teaching their school pupils in future professional life. Our next project, which was offered to students to work, it was to elaborate the complex of the dynamic models for mastering of abstract mathematical concepts. The complex of these models was created in Excel environment with the elements of VBA programming. In the process of the development of these models, Students, like in previous project, were involved in the mathematical model building, then its visualization in dynamic computer model, and research tasks inventing to manipulate the model and learn the abstract concepts, which is incredibly important because lots of mathematical concepts really are very abstract, and it's quite difficult for both students and school children to realize them perfectly well, moreover in context of links between different subjects. The complex embraces some groups of models. The first group includes 3 models, and it is aimed at the understanding the essence of the derivative concepts, its relations to the limit notion, its geometric and physical interpretation. Second group is devoted to the study of the concepts of continuity and discontinuity of the function, awareness of the condition of continuity of the function, and so on. The complex of the models of this complex are also dynamic ones, and there are special elements, also sliders, which allow to manipulate with the parameters of the model and see immediately the changes in functions behavior, and make conclusions as for different tasks which are given also to the potential trainees. The next group of complex focuses on the investigation of growth and decrease of a function. These models can be used to study the behavior of the tangent to the curve when passing via the points of maximum and minimum of the function, and the necessary and sufficient conditions for the extremum existing. The work with the models can be organized as a set of explorative tasks. In particular, it's good to involve trainees into activity like this one, to observe the behavior of the tangent to the curve, to understand, to use the scroll bar, decrease the increment for x to 0, and find out how the tangent looks at the point, what is the value of the slope has, and so on. The episodes of exploration based on the model's extremum is shown on the screen, which illustrates the Forma theorem. The final group of models contains the models which focuses on learning of the definite integral concept. So the students' project activity upon the project number 2 allowed them to practice their own modeling skills, to find the ways how to visualize abstract mathematical concepts and to realize them better themselves, to establish connections between concepts efficiently, to realize personal cognitive activity and stimulate their investigative intuition. Among the topics of the projects offered to students, there was also a project focused on the modeling of the parallel processes with the help of P3 nets. P3 nets theory give powerful facilities for dynamic models building and enable comprehensive learning of the process peculiarities. According to this theory, a P3 net can be defined as a 2-pi-type oriented graph where there are 2 types of vertices. There are places, which are signed with circles, and transitions, which are signed with bars. The places can accommodate tokens that can move around the places, and in such a way it can be imitated the dynamic. We would like to highlight the P3-net benefits in the educational context. The formalism of P3-nets has intuitively clear means which correspond to real objects, events and their interactions, which facilitate building of the real process model. P3-nets enable to demonstrate the interaction of the process components in its dynamics that can be visualized in computer interpretation of the net, and facilities of manipulation with the net's parameters and changing its state with immediate visualization make them really powerful instrument for students learning to model and simulate various processes during their training. The basics of P3-net theory were applied to the development of the mobile Android application P3-net Skill Toolkit, which was created in our department. P3-net Toolkit enables to design your own P3-net in order to model a process, to modify the net parameters with the aim of simulation of various scenarios of the process evaluation, and to explore their peculiarities. In particular, trainees were offered to model the traffic control with the traffic lights, for example, and solve their some interesting tasks. For students, it was also beneficial to model the process of mass service on the examples of colloquial exam passing, and the task for students was to build a model of passing an exam by 4 students, for example, to 1 teacher, and trainees have to imitate different scenarios of the given process. So when all 4 students are waiting for the turn, when 2 students are waiting and 1 student is passing his exam, so the teacher is busy and unavailable, and 1 student has already passed it, and some other scenarios of such process. Also at this project, students were offered a real-life task as for simulation of a safe one-way movement on the railway segment of given configuration that consists of railway drives with semaphores and indicators of occupation. To provide effective modeling and simulation activity, trainees were involved and encouraged to analyze the given configuration and decide how many places and transitions they need and how to join them in order to create correct P3-net and to obtain the necessary shape of the road, what kind of initial marking to determine, and so on. And afterwards they had to solve problems connected with the safe movement, the peculiarities of configuration, and so on. So the students' activity within this project, P3-net's modeling, stimulated their interest as for processes exploring, imitating their different scenarios, their critical estimation, encouraged students to inquiry-based learning and develop their modeling, helped them to establish efficiently connections between process components, and stimulated personal cognitive eagerness. Summing up the students' activity upon the examples which we have provided and some other projects which we used to involve students into modeling activity, we would like to say the following. The students were involved into the complex of cognitive activities. They practiced their own modeling skills, experienced their own simulation and investigation activities, and prepared special didactic support to involve their potential trainees into manipulating the created models. Thus, the computer modeling encouraged students to reveal and demonstrate in action the wholeness of the learned concepts, learning and mastering them independently and actively at the same time, what is really crucial in the context of holistic education. So, on the whole, after this creating projects and involving students into this activity, we provided special empirical research on purpose of the revealing the impact of computer modeling on the results of the holistic training. It was done on a total of 96 students of Kharkiv National Pedagogical University. In order to provide this research and to verify everything, we had to create appropriate criteria system to provide validated empirical research. Our prediction was that the project activity is going to be promote for the students active creation of links between concepts, increase of functional links quantity in the area of concentrate knowledge, and efficient satisfaction of personal cognitive needs. So among the quotients that can display the information of pre-service teachers' holistic knowledge, it might be knowledge characteristics and exactly knowledge depth and systemacy, and students' cognitive eagerness. In our current research, we focused exactly on cognitive eagerness and its forming and learning. The matter is that one of the core problems of science and mathematics teachers' preparation in Ukraine nowadays is decreasing students' eagerness to learn their core subjects during professional training and consequently losing the interest to their future job. There is such a negative tendency. So we found it essential to influence exactly on cognitive eagerness via modeling and consequently to verify our influence. On the other hand, our observations on the students' behavior and performance during their project activity testified the growth of their eagerness to learn actively, to find out, to test and explore knowledge independently, in groups, and really enthusiastically. On balance, we could predict positive changes in their cognitive eagerness. It was determined the system of criteria, the indicators and rules of the measuring according to which it is possible to detect the type of formed students' cognitive eagerness. Either it is realized creative, realized reconstructive, executive, or potential, which means that it is unrealized. The program of observation and survey included investigating the group of indicators which you can see on the screen. It was also created a scale of indicators measuring according to which we could detect the type of students' cognitive activity. There were two groups created, experimental and control group, and the cognitive eagerness was measured using the scale which I have told about. As a result, we could compare average growth of students' cognitive eagerness in experimental and control groups and used special statistic criteria which indicated that the detected difference in students' cognitive eagerness was significant. Thus, the empirical research demonstrated positive impact on the computer modeling project activity on the outcome of pre-service teachers' holistic training exactly on their cognitive eagerness. Our observations and test works during empirical research showed that the combination of typical teaching methods and involving students into computer modeling caused the students' relevant associations, contributed to the forming of students' generalized knowledge, and created conditions for their flexible applying, facilitated revealing in action the wholeness of the explored concepts, learning them independently and actively at the same time. In such a way, holistic learning found their complete realization. That's all. Thank you for your attention, and I'm ready to answer your questions.